Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. Today, we're starting one of the most useful sets of formulas in trigonometry, the sum and difference identities. These formulas allow us to evaluate trig values at combined angles. It also allows us to simplify expressions and eventually prove other powerful identities. By the end of this video, you'll be able to understand where the identities come from, evaluate trig functions at non-special angles using the special angles, and simplify expressions using these identities. So what are the sum and difference identities? We have 3 of them on the screen here. They're just combining angles, either by adding them or subtracting them. So this sign that you see here, that's our plus minus sign, meaning we're either adding our angles alpha and beta, or we're taking our angle alpha and then subtracting beta. The important thing to note here is that for sine of alpha plus beta, the signage stays the same. So what that means is if we have sine of alpha plus beta, then it's equal to sine alpha cos beta plus cos alpha sine beta. Whereas for the cosine formula, we start with plus minus, but notice how the signs are flipped here. So this means that if we're adding 2 angles for our cosine, then we're going to be subtracting the 2 expressions here. In other words, the order matters. So if you're using the top operator here, then you're using the top operator here. If you're using the bottom operator here, then you keep using the bottom operator. If you want, you can write these down somewhere on the side so that you have them accessible as we work through a couple of examples. So let's take a look at our first example. We want to evaluate sine of 75 degrees, but notice how 75 degrees is not one of our special angles. So before knowing the sum and difference identities, we would have had to use a calculator. However, now that we have this new identity at our disposal, we can actually break 75 degrees down into 45 degrees and 30 degrees. So this is 45 plus 30, both of which are special angles. So that means we can write sine of 75 degrees as a sum where we have sine of 45 degrees plus 30 degrees. And now we can use our sum and difference identity to split this up. So that tells us this is equal to, and I have the formula up top, this would be sine of the first angle multiplied by cosine of the second angle, and then we keep the same sign, so plus. And now we have cosine of the first angle multiplied by sine of the second angle. And now we're able to evaluate all of these without a calculator. So sine 45 degrees is 1 over root 2. Cosine of 30 degrees is root 3 over 2. Plus cosine of 45 degrees is 1 over root 2. And sine of 30 degrees is 1 over 2. And now adding them together, we get this is root 3 plus 1 over 2 root 2. Now the other angle that we're asked to evaluate is tan of pi over 12. So the first thing we need to do is we need to rewrite the angle, which is pi over 12, in terms of 2 special angles, because that's the only way we're able to evaluate this without a calculator. So if you play around with that for a little bit, you'll realize that pi over 12 is equal to pi over 3 minus pi over 4. So that means we can write tan of pi over 12 is equal to tan of pi over 3 minus pi over 4. And now using our identity, we can rewrite this. So this is going to be tan of our first angle, which is pi over 3, minus tan of our second angle, which is pi over 4. And this is over 1 plus tan of the first angle, so pi over 3, multiplied by tan of the second angle, which is pi over 4. And now we can evaluate these special angles. So this is equal to 10 of pi over 3 is root 3. 10 of pi over 4 is just equal to 1. And this is over 1 plus root 3 times 1. So then our final answer is just going to be root 3 minus 1 over 1 plus root 3. And now for our next example, we have something that looks quite complicated. So we're actually going to take a moment here and not just jump blindly into this. Because if we're jumping blindly into this, what we would do is we would think that, oh, we have a cosine of two angles added together here. So we're going to use our identity and split this up. So this is going to now become cos of x, cos of pi over 3 minus sine x, sine pi over 3. And now we're going to have to multiply this entire expression by our sine pi over 6. And then we have to do something similar for this expression here. So as you can see, that's going to get really messy. So let's actually erase that and then take a look to see if we can actually make this problem simpler. So what I want to draw your attention to is the fact that we have this entire angle here, which is x plus pi over 3, and it shows up again right over here. And then our other angle, which is pi over 6, which shows up here, and it shows up again right over here. So let's actually go ahead and do a substitution for them, just so that this can look a little bit simpler. We're going to let A be x plus pi over 3. And then we're going to let B be equal to our other angle, which is pi over 6. And now we can go ahead and rewrite this entire expression in terms of A and B. So what we get is we have cosine of A times sine of B plus sine of A times cosine of B. But hey, this actually looks very familiar. This is the sum identity for sine of A plus B. We just have these two terms that have switched places. So this is equal to sine of A plus B. So now we're going to go ahead and do our substitution back. So we get sine of A plus B is equal to sine of, and since our A is x plus pi over 3, and our B is pi over 6, we can substitute it in and then reevaluate. So why are we doing this? Well, this is because we can actually simplify this because pi over 3 plus pi over 6 is equal to pi over 2. So this is just sine of x plus pi over 2. And now instead of having 3 terms in here, we only have 2 terms because we have combined the pi over 3 and the pi over 6. And now it's time for us to use our sum identity again to split this up. So we get this is equal to sine x times cosine of pi over 2 plus cos x times sine of pi over 2. Now cosine of pi over 2, that is just equal to 0. And sine of pi over 2 is equal to 1. So then we get this is equal to, the first term is going to be sine x times 0, which is just going to be 0. And then the second term is going to be cos x times 1, which means we just end up with cos x. So now this entire complicated looking expression actually just simplifies to cosine of x. And now let's go ahead and do a recap of everything that we covered in this video. We went over the 3 main sum and difference identities and what the plus minus or the minus plus sign in the identities actually mean. We learned how to evaluate non-special angles by breaking them up into special angles. And in our last example, we learned how to simplify expressions by using the identities in reverse. And now you have the core toolkit needed for more interesting and deeper problems, which we will start to explore in the next video. So now it is your turn to give this a try. Can you evaluate cosine of 105 degrees by using a sum and difference identity? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on trig identities in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.